Okay, here I'm going to show you how to run a deformable wall simulation. So let's say we start with a simulation that you already have that you can run in rigid mode. I'm going to show you now how you can change this simulation so that you can run a deformable wall simulation instead. And really the only three, so here's your simulation files for the rigid simulation. So in this case we have a one inlet and one outlet geometry where at the inlet you're prescribing a flow velocity, and at the outlet you have a GEM-BC boundary condition. And so here are your simulation files for the rigid case. The only thing you have to do to make this a deformable wall simulation is you have to change three files, and these are the three files you have to change, and the other ones, the other files, you can use the same ones. So I'm going to show you how you're going to change these three files to make this a deformable wall simulation. So let's look at the first file, the solver.imp. So here's your solver.imp, and the only thing, so here's a template, and I've included this a template in with the tutorial. So the only thing really you have to change is this flag here, deformable wall. You want to change this to true. And so now the solver is going to think you're trying to run a deformable simulation. It's going to look for these parameters. And so the way that you would set these parameters is you can ignore these things here. Density of the wall, you can ignore that as well. So here you want to set the thickness of your wall, and then here you want to set the elastic modulus, and it has to be in the same unit that you're running the simulation in. And so these are the only two things you have to set in the solver. So, and that's really simple. That's all you have to do. You don't have to change anything else. So you save these changes and you exit, and so you've taken care of this file right here. And so now I'm going to show you how you're going to get these two files for the deformable wall simulation. And so in order to do that, I'm going to go into the mesh folder that we have for this simulation, which I have right here. Okay, so here's our mesh. What we have to do to get those two files for the deformable simulation is that we have to run the pre-solver twice with different parameters. I'm going to show you how to do that. So I'm going to open up this Supre file, or the CVP file, and the first time that we're going to run the pre-solver, we're going to create a restart file for the rigid case. And so here's a template, and the way that you would set up this pre-solver, the Supre file, is basically everything is exactly the same as you would have in for your rigid simulation, except you're going to add this one line here to set the initial pressure. And so what this is going to do is this will set all the pressures in all the node in your domain to this pressure. And the way that you should choose your pressure is that you should choose your average pressure that you would expect to see in your simulation. If it's pulsatile, you can take the average pressure over time across the cardiac cycle, or alternatively, you can just use the initial pressure that you would expect to see in your pulsatile simulation. But just choose this pressure to something that's close to the range, the operating range of your simulation. And so that's all you have to do for this rigid part of the rigid Supre file. And so what we're going to do now is we're going to run this file with the pre-solver. Okay, so I'm going to open up terminal, go to the folder, and I'm going to go pre-solver, and I'm going to run this file right here, rigid mesh 3. Okay. So what this does is it creates a restart file that contains your initial values, the initial conditions of your simulation, and it's going to contain the pressure is going to be all the nodes will have the pressure that you set it. Okay, so that's the first part. And then next, what you have to do is you have to run the pre-solver again, but this time with a different Supre file to get your deformable conditions. And so here's a template for the second Supre file that you have to run. And I'll explain what's going on here. So you prescribe velocity. So since we're prescribing inflow, then this is the same as a rigid simulation. And then you're going to prescribe a no slip condition to the part of your wall that is rigid. So your whole model doesn't have to be deformable. You can set parts of the model to be deformable and parts of it to be rigid. So a lot of times that you might want to set the inlet, the region near the inlet or the outlet to be rigid to improve your stability. So any part of your model that you want to be rigid, you're going to prescribe a no slip condition to the MBC file. And then here, you're going to have 2 lines added here. And what you're going to do is you're going to set deformable wall to the part of your model that is deformable. And you're going to set it to the EBC file, not the MBC. So you want to prescribe the deformability to the element. And then you're going to add this line, the fixed free edge, that this line prevents, basically it fixes the outlet of your wall so that it doesn't move. And that's also something to help with the stability of your simulation. And then you're just going to set, this is the same as your rigid simulation. You set your 0 pressure for your outlet, and then you set your surface ID. And then you're going to add this block of text right here. And this, so this one, you want to set, again, your EBC file for the part of the wall that is deformable. And then you're going to set your elastic modulus right here. And then this is your Poisson's ratio. And then this is your wall thickness. And then this you can just leave as it is and not worry about it. Okay, so once you've got these things, what you want to do is then you want to write a geom BC with these properties. So this geom BC that you write will contain information about the deformability or the properties of your deformable wall. Okay, and then now the next thing you want to do is that you want to change the restart file that we created in our last step here. You want to add a field to this restart file, which is the displacement field, which is required for your deformable simulation. So here, what you want to do is you want to set the pressure that we talked about. You want to set initial pressure for your deformable simulation, and then once you set this pressure, then you have this line that solves the wall motion based on this static pressure that you set. And then it's going to use this to calculate your initial displacement of the wall. And then this line basically writes the calculation of the wall displacement and add it to the restart file. So this is the second Supre file that you have to run. So let's just run it here. Okay, so now it's calculating all the displacements and then now writing it to the restart file. Okay, so that's it. So now you've got the restart and you've got the geom BC. And all you have to do now is you replace your old geom BC and the restart with the new one. So I'm just going to drag it right here and I'm going to replace. And that's it. So now you have all the file that you need to run a deformable wall simulation. So I'm going to, at the end of the video here, I'm going to spend a couple minutes to talk about if you're having problems with stability in your deformable wall simulation. So inherently, a deformable simulation is going to be less stable than a rigid one. And so, you can go through this process and try to run the simulation. But then if you're running into divergence problems, I'm going to just spend a few minutes to talk about a alternate way you can kind of brute force initialize your deformable simulation to make it more stable and to make it converge. And so I'm just going to kind of write down these steps for you here. So let's say you have a terrible simulation that won't converge. And so to help with the convergence, there's a couple things. This is one pipeline of things that you can follow to try to fix that problem. So first of all, you would run a rigid simulation. Okay, rigid with steady flow. Okay, and the way that you would you would use the same geometry, and then you would set the flow. So if ultimately you want to run a pulsatile simulation, you would set the flow in this steady simulation to be the average flow that you would expect in your pulsatile simulation, and you would also set the boundary condition such that you would get the same pressure, the same average pressure in your steady simulation. Okay, so you run a rigid simulation, a rigid steady simulation. You don't have to run it for long, just a couple hundred steps is probably just enough so that your pressure and your flow will stabilize in your domain. Okay, so once you've run the simulation, you want to now extract the results of this simulation. You want to basically get the information from the last time step of this simulation so that you can use the result as the initial condition of your next simulation. And so what you want to do is you can go to the folder where all the restart files are saved, and then you can type in this command. Oh, let me try to find the... Okay, so you want to type in this command, and what this is going to do, so you want one here. What this is going to do is when you run this command, and here's what you put the number of your last time step. So let's say if you run 500 steps, then you put 500 here. So what this is going to do is it's going to create a restart file, a restart.0.1 file that contains the simulation results from this simulation that you can use in the next simulation. Okay, so once you've obtained this new restart file, you run another simulation, and this time it's going to be a deformable and steady simulation. Okay, so this simulation is going to be a little bit more difficult to converge than this one, but now you're using a good initial condition. You're using the restart file from this simulation. So you would go through kind of the same process to create the geombc file for this deformable simulation, but then you would basically just take the restart file from this and then use it for this simulation. Okay, so once you've done that, you do the post solver again to extract results. And for this one, you might run it for a little bit longer. You would run it until the pressure levels out, basically. And so you can determine, you can look at the pressure curve and see if it's still oscillating, and you want to just run it until it stops, the pressure stops oscillating. Okay, so you extract the simulation result using the same command from this deformable steady simulation. And then finally, now using the restart file, you can run your deformable simulation. And so again, you just basically prepare your simulation and then replace your restart file with the restart that you get from this simulation right here. So hopefully, if you do this correctly, and everything will go smoothly and your simulation will converge. And a lot of times, the stability of the simulation just has to do with the geometry. So if you're using a very complicated geometry, then the first the first part of the video, the step that I go through, is kind of a shortcut to get your simulation running. So if that doesn't work, if your geometry is too complicated to be stable that way, then you can go through this process and try to see if you can